Okay, I'm back. Luckily the Windex took care of it. Woo-hoo. So yeah, apparently as it gets colder in the barn, the dry erase does not come off the board as well. Okay, so we're working on these chain rule type guys. So let's see what the next one is that I've got here. So here we have f of x equals, oops, that is not what we have there, x e to the negative 2x. Okay, so they are combining this time what we've seen over here, but then also with the product rule. Okay, so if we want the derivative here, again, product rule says take the derivative of the first guy, which is just 1, and follow it by the second guy. Plus, okay, then we're going to leave the first guy, x, and we're going to take the derivative of the second guy. But now remember, derivative of the second guy means write this guy down, and then take the derivative of the exponent, so times negative 2. Okay, so e to the x is its own, so you just write it down, but then you have to take the derivative of the inside. So we end up with e to the negative 2x, and then that'll turn that into a minus 2x e to the negative 2x. Okay, so again, the derivative itself is not necessarily the prettiest because it's definitely going to have e's running around it, but it's not so bad, okay? All right, one more here. Let's say we had g of t equals e to the 3t squared minus 2t. So again, as we're saying, they're going to put a lot of things up there in the exponent for you. So let's say that it looked something like this guy. Okay. If we want the derivative here, write that guy down, e to the 3t squared minus 2t, okay, just write it down, but then we have to take the derivative of the inside. So the derivative of the exponent ends up being 6t minus 2. Okay, that look good to everybody? Okie dokie. So remember that e to the x is its own derivative, but most of the time you're going to have to combine that with the chain rule or the product rule, okay? So definitely be prepared for that. Now let's use functions with e to the x in them and do some of the stuff that we've been doing in the past. So let's find inflection points. Oh, wait, let me put my Windex. Or not. Okay, so let's find inflection points. Okay, so as a reminder, when something says to find inflection points, that means that we are looking for the second derivative, right? So we're going for the second derivative, and we're going to set it equal to 0. Second derivative equal 0. Okay. All right, so the function that they give us is f of x equals e to the negative x squared. Okay, so we've got our e in there, and then again, the exponent itself is a little bit ugly, so we've got that chain rule going on. So we got to go for the first derivative, so we'll go f prime of x, and remember the idea is write this guy down, and then the derivative of the inside, which in this case is going to be negative 2x. And because we have to work with this one again, I'm just going to flip it around just so it looks a little bit nicer. Okay, so like that instead. Because we're not done, are we? That was only the first derivative. So now we have to go for the second derivative. Now when we go for the second derivative, because of this guy right here, we are now into the product rule, aren't we? So the product rule says, take the derivative of the first part, which in our case would be -2, leave the second part, plus leave the first part, -2x, take the derivative of the second part, so e to the -x squared, but immediately followed by the derivative of the exponent, which is -2x. So now, as I said, I know that now there's all these e to the x's and stuff running around, it starts to look ugly, so let's definitely simplify here. So -2e to the -x squared. And then here we've got two negatives, so this is going to stay a plus, but it's going to end up being 4x squared e to the -x squared. Okay, that look good to everybody? All right. Now we're going to set this guy equal to 0. -2e to the -x squared plus 4x squared e to the -x squared equals 0. Okay, now what happens is we're going to have to rely on some of the rules that we have back for exponentials. Okay, so some of that review that we did. So this definitely looks ugly. This is probably one of the uglier ones we've seen, but in actuality, it's actually one of the nicer ones we've seen. So when you've got that e to the x going on there, the first thing you want to do now is factor out the e to the x, because most likely it's going to be in all of the different terms. And it is e to the -x squared, e to the -x squared. And as well as that, we could factor out the -2 as well, couldn't we? So we can factor out -2 e to the -x squared. And if we take all of that out, it's going to leave us a 1 left from this one. It's going to change the sign on this, boop. If we take out a 2, a 2, there'll still be a 2 left. We'll still have the x squared left, but we won't have this guy anymore, will we? Right, so we've taken out a 2 and the e to the -x squared. So that's all pulled out. And then we have this. Okay, now, think about that graph that we drew last time. E to the -x squared, e to the x. Is there any way that e to the x is going to be equal to 0? Okay, if you plug in 0, you get 1. If you plug in negative numbers, you get smaller numbers. If you plug in positive numbers, you get bigger numbers. So e to the x itself, this can never equal 0. Okay, so this never equals 0. Now, what we're looking for is where it equals 0. So if it never equals 0, can we just forget about that part of the equation? We can. So what ends up happening is once you factor out that e to the x part of this, it just basically goes away. It doesn't affect us because we're setting this equal to 0. Give me a moment while I work on this board. Okay, so this part never equals 0, so we can think about canceling the whole thing out. And what we actually are left with is just 1 minus 2x squared equals 0, okay? So remember, never equals 0. So factor it out and then just forget about it, okay? Now here, we'll get 1 equals 2x squared. So 1/2 equals x squared, right? So if we take the square root of both sides, we end up with x equals plus or minus the square root of 1/2. And that's all they asked us to do, was to find inflection points, so we don't have to go any further than that. There are 2 of them, plus square root of 1/2 and a minus square root of 1/2. Okay, but this is the biggest key that we want to focus on. I know you guys can set things equal to 0 and solve. The thing is that whenever you have that e to the x, if you can factor it out when it's set equal to 0, it really doesn't affect the problem at all. Okie dokie. So let's look at a word problem then. Which word problem? Let's go with this guy. Oh, hold on, I gotta erase the board in. This is gonna be tedious. Now let's look at a word problem. Okay, so this says the demand for a product is little p equals 56e to the negative 0.000012x. Okay. For P in dollars and X in units. What price will, what are we trying to do here? Maximize the revenue. Okay, so we want to know what price will maximize our revenue if we're given this demand function. Okay, so maximizing means that we're looking for the first derivative and we're going to set that equal to 0, right? Okay, so setting the first derivative equal to 0. The only problem is that they gave us demand and we want revenue. So in order to find revenue, come on, pen. Now there's too much Windex on the board. In order to find, switch colors, see if that is there. There, revenue. We're going to take this guy and we're going to multiply him by x, right? So I'm going to go x times 56e to the negative 0.000012x. And actually, that's not the way we normally see this. And because I do have the whiteboard, I'm going to take a little shortcut here and just erase that and go 56x. So it looks a little bit more like what we're used to seeing. Okay. So now we have our revenue function. We want the derivative of that guy. So because of the x, we got that product rule going on again. And because of the e to the x, we've got the chain rule going on. So let's see what we get for r prime. So derivative of the first guy, which would just be 56, leave the second guy alone, plus leave the first guy, 56x, write down the second guy, and then take the derivative of its exponent, right? So negative 0.000012. Now, at this point, if we wanted, we could multiply 56x times this teeny little decimal here. But thinking about what we did last time, what we should be thinking is factoring out. So we want to get rid of this e part of it, so we're going to factor out. So when we go to factor, in the form it's in right now, they both have a 56 in common, don't they? So we can factor out 56 e to the negative 0.000012x. If we do that, only thing that's left here is a 1. Everybody agree? Okay. And if we take out the 56, the e to the negative blah, 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 all we have here is this guy times an x. So we have minus 0.000012x. And then this whole thing is set equal to 0, okay? Derivative equal to 0. Okay, but just like last time, tell me about this part right here. Any way that's ever going to be equal to 0. Okay, so this is never 0. So really, we're only looking at this guy, 1 minus 0.000012x equal to 0. So we can say that will give us 1 equals 0.000012x. So if we divide 1 divided by 0.000012, boop, I got an x of 83,333.33. All right, so our x ends up being 83,333, and because x was in units, we can pretty much boop go and get rid of those guys there. So just 83,333. But now remember, we've done all this hard work, and yes, it's paid off, but what did they ask us to find? Not the number of units, they wanted to know what price they should ask. So where are we going to take this 83,333? However many threes. We got to go back to the original function, right? The demand function. So we're going to say that P will equal 56 e to the negative 0.000012 times 83,333. So back to the calculator. 56. Remember, use your e to the x, which is along the left-hand column. Negative 0.000012 times 8333. And I end up with a price of $20.60. Alrighty. Right. So remember that the derivative of e to the x is just itself, so that means that really what you're looking for is the chain rule or the product rule. And then remember that whenever you can factor it out when it's set equal to 0, that guy will never equal 0. So factor it out and then just forget about it. All right, you guys. So that does it for e to the x. See, not that bad, right? Okie dokie. I will see you next time.